Welcome to this presentation on the effect of filtering on PID control. We will discretize filtered PID control law. We will repeat it for proportional derivative control law. We will show that bumpless control action is lost in both of these. Recall the filtered derivative mode. Instead of using simple tau d s for the derivative mode, we have a larger denominator term with this tuning parameter capital N, and this is equal to SC by RC. Let us apply backward approximation for all occurrences of S. There are three places where S comes, one here, second one here, third one here. We will substitute for 1 over S as the following, or in terms of Z inverse we get this expression. This is the backward approximation. You can show that the term on the left hand side here can be written like this, where this R1 is yet to be defined. You can show that R1 is given in terms of this term. I would want you to substitute and make sure that you indeed get these two expressions. Alright, let us start with these. Now let me substitute for S. The control law becomes the following. The first one remains as 1. The second term is exactly this, so you just substitute Ts into 1 over 1 minus Z inverse, tau I is here, and then for the third term you have to substitute for S, which will be the reciprocal of this, and then you have the expression for this given here. When you substitute and simplify, you will arrive at this expression. I would want you to verify that you indeed get this expression. Okay, let us start with that expression. Let us simplify this. In the denominator I have 1 minus Z inverse and 1 plus R1 Z inverse. So these two appear in the numerator of the first term, and then further simplifications here, second term and third term. I would want you to derive this expression. When we compare the denominator and numerator with the expression here, namely SC and RC, SC will have up to Z power minus 2. You have Z power minus 2, for example, Z minus 1 whole squared, you get Z power minus 2. For RC we have what you have in the denominator. In this expression for R1 is already given. I asked you to derive in the previous slide. The expressions for S0, S1 and S2 are given in the next slide. They are given here. I would want you to derive every one of these terms. So we start with SC and RC here. The PID control law is given by the following. U of n is control law multiplied by control input, which is E of n. When I substitute for SC and RC from here, I get this expression. Let us cross multiply, we get this control law. So it is 1 minus Z inverse into 1 plus R1 Z inverse times U of n equals this whole thing multiplied by E of n. Now the difference is not of Un. We no longer have delta times Un, but we have difference of this whole thing, not difference of Un, but difference of this whole thing, which is 1 plus R1 Z inverse into U of n. As a result, we notice that the bumpless control action is lost here. So this is the trade-off for introducing the filtering action. Remember, this is the PID control law with filtering and Tc equals Sc. We got a benefit by introducing the filtering action, but we lost some other advantage, that the bumpless control action is lost in this. Suppose we do not want integral mode. So, I have written PD control law, it is no longer PID control law. At times the plant itself may have an integral mode. So, you do not want to include another integral mode in the control law. So, we do not want integral mode. So, we delete the second term. So, here is the control law, which can be simplified easily. The expression for R1 is same as before, and I can cross multiply this to arrive at this control law, and expressions for S0 and S1 are new. You will have to derive these, verify that you indeed get these expressions. This is also not in incremental form. There is also no integral action, because the original control law itself did not have integral action. We started with PD control action, and hence there is no integral form, and we said that this could be because the plant itself might have integral action. For whatever reason, the integral term is not included. With this, we have come to the end of this presentation. Thanks for joining. Goodbye.